When I run my program, it should ask me how many array elements. If I push in 0, it should tell me it should be between 1 and 20. If I put in 21, it should give me the same thing, and every time I hit enter, it should clear. If I select 10 elements in the array, I can put in random numbers 66, 34, 60, 667, 123, 44, 87, 55, 345, and 21, and finally let's put in, just for fun, 88. Now what it should show me here is all the elements in exactly the same order as I had here. This is our unsorted array. If I hit enter, it should show me the same array sorted from largest number to smallest number, and if I hit enter again, it should show me exactly the opposite from smallest to largest. Now since I have an array ordered from smallest to largest, I should at this point be able to do a binary search. And it's going to ask me, type in a number to search. Now if I want to type in one that already exists here, such as 87, I can put in 87, and it's going to tell me that 87 exists at index 5. And let's count. 0, 1, 2, 3, 4, 5. Now this is what we need to show for your program running. Now we can also do what we talked about last time. We can grab everything here and mark it by holding down the left mouse button, selecting this. We can right mouse click, we can say edit, and we can say copy, and then we can paste this into our program. Now this is a run that we've done with 10 elements, and we did find in this case that the element existed. Let's check and run this again with different numbers this time and see that indeed it will come up and say that it doesn't exist if it's not in the array. This time I'm going to pick an array of 10 elements again. I'm going to again type in random numbers. And again, it's going to sort it this way. Now this time we're going to, this is our unsorted array. This is our sorted from highest to lowest, sorted lowest to highest. This time I'm going to pick a number that's not in here. So I'm going to pick 46. So if I type in 46, it's going to tell me value does not exist. So only if the value exists in there will it tell me this is the value and this is its index. And again, what we can do is highlight all this by selecting this, right mouse click, edit, copy, and pasting this example in to our program at the bottom so we can see that our program is indeed working, and it does give us a valid index if it does exist, and it says value does not exist if it doesn't. Now let's see how we'd go about doing our coding. Basically, in the main function, you can have a do while number is greater than max or number is less than 1. And what you can do is use a number sign define max to be 20 or whatever number you want, in this case 20. And so this again is a printf scanf of number. If number is greater than max or number is less than 1, it's going to say number must be between this, and this is what we saw in our program. After that, what we want to do is bring in an array. So you're going to have to define the array. This one I called unsorted, and I'm going to go from 0 to number minus 1. Because if we had a 10 element array, that's going to go from 0 to 9. So this means we're going to again printf scanf the array in here, and then we're going to go from 0 to 9 again, or 0 to number minus 1, and print the array to the screen. The next thing we're going to do is call up a function called lower, and we're going to pass our unsorted array into that, and also the number that we actually had of elements. Then we're going to do the same with upper and sort it differently. Now if we take a look here, what that's really saying is our array called unsorted here, we're going to pass a pointer into that. By saying unsorted, we're going to be passing that array first element in, and what we're doing here is we're going to say downsorted, we're creating another array here, is going to be a copy. So whatever array here unsorted is passed in as a pointer, we're then going to fill up the array downsorted with exactly the same array elements. And then inside this function, once we've brought in the array and made a copy of it, if the value to the left is smaller than the value to the right, we're going to exchange the elements. and that's going to give us a sort that's going to be from largest on the left to smallest on the right. But notice what we've got here. We got k equals 0 to size minus 1, which is 0 to 9, and then here we're going to go j equals that to size minus 2, because the comparisons you're going to have out of 10 is going to be 9 comparisons, not 10. So 0 to 8 will give us our 9 comparisons we're going to do. If this number is size minus 1 or larger, you're going to get random values coming in because it's going to go past the end of the array. Now once we've sorted this, and if this isn't the case, it's just going to go on and we're going to do this a number of times until it's sorted properly, then we're just printing it out. For j equals 0 to size minus 1, we're going to print out that array, and that's what we saw on the screen. Now this second one is pretty much the same. The only real difference in the main part of the code here is instead of less than, it's going to be greater than. We're doing all the same moves here, and we're printing out the array. But at this point, this is where we're calling up the next thing. We're basically saying let's input our search key, and then we're going to say value equals binary search. So we're going to pass this on to a function called binary search, which is going to send to it a pointer to the array, the size of the array, and the key that we're actually inputting here. And then based on what comes back, if the value is minus 1, it means that the value doesn't exist, and if it is existing, we're going to actually put out the search key and the value. So here's what we're passing in. We're passing in again the array in here, the size of the array, and the actual key. Here we can see that we set low to 0, the 0 element, and this is to the maximum element, in this case 9 if it's 0 to 9. And then we're saying as long as low is less than high, then we're going to go through this. Now when low is not less than high, that means it doesn't exist, and we're going to return a minus 1. And if we return a minus 1, it says it doesn't exist. If it does exist, and we keep going through this enough times, we're going to return the actual current index when key does equal this. And so that's the implementation that you're going to need for this, and understanding the structure diagram as you see on here. So all you have to do is turn this into code. The structure diagrams are here, and best of luck.